Welcome to another episode of Love Tech Live. Our challenge today is speeding up our relational database tables using indices. We downloaded some music data from an online API into PostgreSQL tables, and our lookup queries are slowing down due to the millions of records. When facing scaling pain, you always need to evaluate your indexing strategy. In comp sci, there's a known trade-off between time and space complexities. That is, the fastest solutions often require the most space. A prime example of this in databases is with table indices. A table index is like the table of contents at the beginning of a book. It allows quick lookups by listing all of the sections and their page number. It takes a few more pages to print the table of contents, but it saves the researcher's time. A database table index is a quick reference for the database engine to find the records it needs. It takes a bit more space and extra time to do inserts, but the lookup times are much faster. It is up to the discretion of the developer where to put the indices for maximum effect while keeping it as limber as possible. In this lesson, we'll look at two index types we can use in PostgreSQL for faster sorting and for faster string lookups. Alright, let's get to the data. So if you run the \dt command once you've connected to your database, it'll list all the Postgres tables in that database. So once we do that, we can see that we have about 5 or 6 tables. The two main tables that we're going to be looking at here are artist and album table. To view the structure of the table, run the \d+ command followed by the name of the table. So when we do that with the artist table, we see that it consists of 3 really important columns for this demo: the name of the artist, the number of plays, the number of people following. And then there's also summary, which is a text summary, and an artist artwork. When we examine the album structure, the album table structure, we see that there's the album title, the artist title, the number of plays, and the rank, which is an integer where the lower the rank, the better. Next, we'll look at how many rows are in these tables. So when we select count star from artists, we see that there's 110,000 artists. When we select count star from albums, we notice it takes a bit longer. This is because there's so many albums. And this is where the indexing will really help us come up with faster results. So I believe there's 5.3 million albums in this example. The next thing we're going to do is some selections with sorts. In PostgreSQL, to sort a result set, you use the order by clause. So the first query we're going to do is select the top 10 artists by the number of plays, and their name has to start with the word Bob. Notice that % at the end of the like clause. That's an efficient way to do an indexed lookup, or a lookup on an indexed field. If you have the % at the beginning of the like clause, it's not going to buy you anything because you're still going to have to look through all of the keys to see if that text is contained within. But we see we have Bob Dylan, Bob Marley and the Wailers, Bob Sinclair, Bob Seger, so it seems to work. So the next query we're going to do is the same exact select all from artists, order by, except for this time we're going to order by people, that is the number of followers. And we're still going to have the constraint where the name has to start with Bob. We'll move on now to albums. We're going to select the top 10 albums that start with the word bizarre and order by the number of plays that that album has incurred. Notice that the album query here is taking a bit longer than the artist query due to the number of albums. Next, we're going to do the same thing again with the album table, except for we're going to look for albums that start with the word amazing, and we're going to order by their rank, this time ascending. We still want the top performing songs, and we get our result set. So now the question is, how do we speed this up by adding indexes? So there's two types of indexes that we're going to address here. The first type is a single text index. The way that PostgreSQL does this behind the scenes is with a binary tree, which is an approximately equal weighted tree so that all lookups can be done in a reasonably fast amount of time. The first index that we're going to create is a text index for our album name in our album table. It's important to note that each index needs to have a unique name. And I had to switch users just there because I was in with a user that wasn't privileged to create indexes. So make sure that you're privileged. You might have to use the Postgres user in order to break through or to assign more privileges to your other users. So you can see that the indexes take a bit of time because there's so many rows that have to be processed. Now I made a mistake here and I created the wrong named index. So what I'm going to do is I'm going to delete the index that I wrongly named by using the drop index command followed by the name of the index. And then I'm going to fix the name of the mistaken index. So this is creating an artist's table index on the name text column. Now here's where it gets interesting. Now we're going to make sorting indexes. So this is going to really help us sort our albums by plays, descending, with nulls last. And then we're going to do the same thing with our album based on rank. And then the same thing for our artist table based on the plays, and then again based on the people. Now when you're doing an index for sorting optimization and performance, you're going to want to pick whether the direction is descending or ascending, and whether to put the nulls first or last. So now that we have these indexes installed, we can run these queries much faster. It still takes a little bit of time for the album queries because there's so many, but at least now we're getting prompt results that we can use for our application. So let's look at a little bit of documentation from PostgreSQL so that you can learn how to read it and help yourself in the future. So this is the documentation for the create index command, and you always want to ask yourself when creating a new index whether it should be a unique index. A unique index means you never have any duplicates for that field. It causes the system to check for duplicate values in the table each time data is added, in which case it will generate an error. Also, the typical database table of records with unique IDs should be primary keys. When designing your table, it's usually a good idea to make the main ID for each table the primary key for the table. Primary keys automatically create fast indexes and ensure uniqueness. Note, in many cases such as association tables, you won't even want a primary key. You can have multi-column indexes as well, if you often look up using the same 2 or 3 columns.
Thanks for watching. If you love music, go to mymusi.cc today for great cloud music storage for less than 1/3 of a cent per gigabyte. Beautiful players on all your internet devices via the browser with no apps to install. Just drag and drop your music from your computers, files, or your iTunes.